Welcome to the webinar Cephalometry in Prosthetic Dentistry and Oral Rehabilitation. We start with Season 1, the Principles of Cephalometry. Module 1, Basic Principles of a Cephalometric Analysis. My name is Gregor Slavicek and I represent the OREHAB Academy. Here the overview about Season 1. Principles of cephalometry. We start with the basic principles of a cephalometric analysis. Then we talk about the principles of cephalometric measurements. Then the systematic analysis, starting with anatomical landmarks, the landmarks of the base of the skull, the landmarks of maxilla and mandible, dental landmarks, and the landmarks of the profile. After that, we will talk about planes and constructed landmarks. And finally, we will spend some time to discuss the measurements, cephalometric measurements. So the principle of a cephalometric analysis starts with the recording technique. And it is the situation that we have a tubus here and the head of the patient in a quite wide distance, usually in the traditional way, and behind this head is the film. And the distance is quite wide in traditional cephalostats. The wider the distance, the better. The less magnification, the less distortion. So in the beginning, there were up to 4 or 5 meters distance from the tube to the film. Now the systems are shrinked, but still we have this factor to be considered. In German, the term Fernröntgen is used, so it means far X-ray, meaning the wide distance between the tubus and the film. In addition, it's very important to understand that the head has to be in a standardized position within the cephalostat, and here we use different landmarks. One of these landmarks is Frankfurt horizontal plane. This Frankfurt horizontal plane of the patient, here it is determined by the landmark on the skin, which is the suborbital point, and the porus acousticus externus or the meatus acousticus externus. And this plane of the patient should be more or less parallel to the floor. In addition, we have an element which supports the patient to maintain this position. This is glabellar support, anterior here. And the patient is stabilized also with 2 parts which are in the meatus of the right and the left side of the patient. So in this position, the spine is quite relaxed and the head is more or less in a natural position. In addition, we need a calibrator here. So we have the possibility to recalculate the magnification factor. And we want to see all the structures needed, so the cervical spine, the hyoid bone, mandibular and maxilla, the cranial base, external and internal, and most of the skull, including the profile. So it's important to have a good team, trained team, to make a proper analysis. The aim of a cephalometric analyzing prosthetic restoration and oral rehabilitation are manifold. We want to understand the individual skeletal structure. We want to understand the position of occlusion within the so-called skeletal frame. We want to analyze occlusion in relation to the cranial base and especially in relation to the TMJ. We want to plan the prosthetic restoration and the oral rehabilitation. We want to measure or calculate the functional determinants of occlusion. These three examples of an Ceph here should give you already the imagination how different the skeletal situation might be in our patients. We want to understand the individual skeletal structure. So our reference in dentistry, in oral rehabilitation, in prosthetic rehabilitation is the cranial base, the anterior cranial base. For our purposes, this is a fixed parameter. We are not changing this parameter. We are able to change some parameters in the occlusion, but also on the maxilla and the mandible. So first of all, in the cephalometric analysis, we want to understand the position of the maxilla in relation to the cranial base and the position of the mandible in relation to the cranial base. And then, of course, the relationship of maxilla and mandible. Here, for example, the position of the maxilla can be measured and judged as neutral, but also the position of the mandible seems in this example to be neutral. So we will learn how to use this information to judge the skeletal class. Here, the position of the maxilla is retrognate. The position of the mandible is prognate. Retrognatic to prognatic, this is skeletal class 3. The opposite, maxilla is prognatic, mandible is retrognatic, pro to retro, a clear skeletal class 2. In addition, we want to understand the vertical dimension and the growth tendency. For that, we have structures to be considered as the anterior cranial base, the cranial base in front of foramen magnum, the clivus, then the posterior and the posterior mandibular structures, the lower border of the mandible, the maxilla or the midface, and finally the tooth-related structures here, alveolar process, upper and lower. From that we can understand the vertical dimension in total, but also of different parts. For example, here lower facial height. And what we do is we measure the posterior height, we measure the anterior height, and we have a relationship of these two parameters. Then we have the midface and the lower face. All these parameters are used to understand individual vertical dimension and the growth pattern of this skull, of this patient. Here 3 examples. A typical brachio, a typical mesio and a typical dolchofacial pattern, growth pattern. The mesiocephal or the mesiofacial growth pattern is characterized in a lower posterior vertical dimension compared to a higher anterior vertical dimension, but they are in harmony. If the posterior vertical height is increasing, especially compared to the anterior, we have an brachiofacial type. Or if the anterior part has a quite high dimension, vertical dimension, and the posterior is not quite developed in vertical direction, we have a dolchofacial pattern. Second, we want to understand the position of the occlusal within the skeletal frame. Here we can see the skeletal frame consists from different planes representing the upper and the lower jaw. Then we have an anterior and a posterior frame, part of the frame, and we have occlusal plane, here red. Occlusal plane represents very good the quite complex three-dimensional occlusion. So simplified, we use the occlusal plane as a parameter to understand the relationship of this occlusion within the skeletal structures. And we can already see the principle of the stomatognatic system of a human being. Occlusion is quite constant placed within these two jaws. All the malocclusion can be explained, can be described, but also in malocclusion we can see a very good relationship to the upper and lower reference plane of this denture frame, of the skeletal frame. The upper is palatal plane, the lower is mandibular plane. The occlusal plane has to be in harmony. And within these webinars, we will learn that if we follow this concept denture frame, we can see that occlusion is a major cause for an dysknatic development, and not the dysknatic development is the main problem for an malocclusion development. Third, we want to use the Ceph to understand, to analyze occlusion in relation to the cranial base, and especially to the TMJ. Here the TMJ is visible on the Ceph, and we can import condylographic tracing, the movement pattern, the trajectories of the hinge axis into the Ceph, and relate these parameters to occlusion. In addition, we can add now the information of the guiding structures anterior, the lingual morphology, to the Ceph, and then we have this dynamic situation to be analyzed, to be understood, and in addition to be used in the therapeutical strategy in oral rehabilitation. Finally, to plan the prosthetic restoration, to plan the oral rehabilitation, that's a wonderful tool, the Ceph. Here we can calculate, measure, determine the functional parameters of occlusion, such as lower facial height, how much we can increase or should increase the lower facial height by the incisional pin of the articulator, how to change occlusal plane inclination, the TPO, distance to plane of occlusion, to calculate radius curve of SPE, and. So the Ceph is a gnatological tool. I know it was developed mainly for orthodontic purposes, but if we use it correct, it's a wonderful tool in prosthetic and oral rehabilitation. For me, it is a gnatological tool perfectly fitting to the other instruments, gnatological instruments, such as condylography and articulator. And here we have already some examples which parameters can be used to understand the problem and to plan the new occlusion. Back to the principles, enlargement and double contour. This is what we have to consider. We are facing this. That's because of this technique. We have a film and parts of the skull are close and other parts are far from the film. And because of the projection, we have double contours. But these double contours are often helpful to identify landmarks, anatomical landmarks. So that's a disadvantage of the technique, but an advantage in localizing anatomical structures. The correct procedure for the evaluation of a cephalometric analysis in oral rehabilitation. First of all, we identify anatomical structures. Then, on this tracing, we identify landmarks, particular points exactly defined in the literature. Third, now we can already leave the Ceph and we are focusing only on the tracing, and we are tracing planes. These planes also are exactly defined in the literature, something we have to learn. And then between the planes we can measure particular angles defined exactly in the literature, and based on these measurements we can draw our conclusions. Conclusions such as the skeletal trend is the position of the upper jaw, the position of the lower jaw, the skeletal class, the lower facial height, occlusal plane inclination is, and so on. All these parameters can be now developed. And finally, based on these measurements, we can do the step number 6, the planning. We have to change lower facial height to this degree, and that means a change about 5 degrees. And then we will learn how to transfer this to the articulator, to the incisional pin of the articulator. Then, one of the most important parameters is the occlusal plane inclination, how to change it, what is correct. And as occlusion is never a flat situation, it is always a curved, has a curved parameter. This is curve of SPE. And this also is a parameter which can be analyzed and calculated and planned by the Ceph. Radius curve of SPE in millimeter. So here We're already done with our Module 1, Basic Principles of a Cephalometric Analysis, and I'm looking forward to meet you again in Module 2, the Principles of the Cephalometric Measurements.